Okay, hello, I'm Adrian Bowyer, I'm from the University of Bath in the UK, and I started the RepRap project, which is a project to make a 3D printer that can print itself. I think the place to begin is how the machine is actually building objects. What it's doing is it's taking this plastic filament, this solid plastic filament, and it gets driven down through here by this electric motor into a heated chamber at the bottom here, where it melts and comes out of a very small nozzle. So you've got a fine stream of plastic coming out, a little bit like a glue gun, only with a much smaller diameter. And the plastic comes out about that wide, which is 0.5 millimeter wide. And the way the machine then works is, as you can see, it's moving around. It builds a layer at the bottom on this blue layer here, which is the base which it builds on. And then, having built that layer, it drops down, as you're about to see it do. There it goes. It then builds the next layer and the next layer, and as each layer is built above the other layer, eventually you end up with the finished part. This is the main motherboard, which has the master controller in it. And then there's this board here, which is the board controlling the extruder, the device that's laying down the plastic. And in a machine which had multiple extruders, you'd have as many of these boards as you had extruders. And then at the background there, which you can't quite see from this angle, underneath here, there are 3 stepper controller boards that control the X, Y, and Z motion. And then finally, there's a little USB interface board there, that's just there, which handles communication with the computer. The next generation of this board is going to have the USB on it, so it won't need that USB board.
The actual percentage of RepRap that is able to self-replicate is...
If you don't count nuts and bolts, then it's 50%. But if you count nuts and bolts, almost the entire machine is made of nothing but nuts and bolts. So that doesn't actually tell you very much at all, because there are just so many of them in it. And the rule is, it makes it itself, or if it doesn't make it itself, like for example this threaded rod, it's got to be really easy for anybody to buy it anywhere.
So for someone who's interested in building one of these for themselves, I think earlier you were explaining you probably could get a group of 3 people with the right skill set to do so.
That's the sort of thing that people tend to do. If you need skills in 3 areas: mechanical engineering, electronics, and software. And so typically people might have skills in 1 or 2 of those areas, but most people perhaps not all 3. So what you need is 3 or 4 people who have that skill set to collaborate on making a machine. And when they do so, they'll all teach each other and learn enough that then will be able to go away and make more machines. And of course, once they've got one, they can use it to make the RepRap section parts for the other machines that they might want to make in their group. So it's both educationally reproducing and physically reproducing.
What about these boards? I noticed you've even got them printed with RepRap on them. So are these?
Yeah, these
off-the-shelf parts, nevertheless. Or?
At the moment, these are made by a commercial company, but given that it's an open source design, all the printed circuit designs are in the files you download with the project. So if you can etch your own PCBs, and some people do, then you can make your own boards, of course, if you want. And then you've just got to solder the components onto them, which is fairly straightforward. It's quite easy actually, because they're surface mount components in the main. Though, I suspect that probably a long time in the future, after I'm dead, when Carl Otto first made the motor car, he said, "Oh, how marvellous, what a wonderful thing, you can go away with horses."
So we've got the end product here, which is
a coat hook. Yeah. If that's the wall, there's a wall like that.